Hello, my name is Aiden Mendoza, and today I will be explaining the differences between our original code and the code that we made that modifies the original fractal terrain generation program. So to start out, let me rerun this program. And then as you can see, here is our window. This is our OBJ file that was generated. And that's loaded right here with our fractal terrain OBJ. And we loaded in with a camera viewing it from a 45-degree angle so that we can better see the changes made to the height map using our command line. So let me start out by raising part of it. So let's make it a little significant. I'll go with 40, 50, 10. As you can see, here we have a little bump here that goes up. And then if I were to lower 40, 50, 10, as you can see, it then gets rid of that bump. So let me raise it once more. And then I'll use the command flatten 40, 50, 10. And as we can see, it then flattens it out to a sort of plateau type shape. So, let me go now method by method to show you the differences between the two types of code. So firstly, let's start out with our, not what I wanted to do, adjust height map function. Here we go. So this method, it did not exist in the original code. It was added in the modified version to simplify the process of modifying the terrain's height map. In our case, it uses two nested for loops to iterate over a square area centered around the given x and z coordinate positions. For each dx and dz offset in the square, which would be within the radius of 3, it calculates the distance from the center, and if this point is within the radius, it then increases that corresponding height value in the height map by the specified factor. It also ensures the new height does not exceed the max height, which is defined somewhere else in the program. After making these changes, it allows us, well, it makes it, it saves the terrain to an OBJ file, and then it reloads the 3D model. So it then displays in that JWGL window that we have. And then next we have our inner AHM positive and inner AHM negative. Here's our positive, and here is our negative. So these two recursive methods, they were present in the original code, but so they serve a purpose to adjust the height map, and they use a recursive approach. So both these methods, they adjust the height at a specific point, and then they recursively call themselves for neighboring points within a certain radius. This decreases the strength parameter at each step. So this allows for a more natural and gradual terrain deformation, since the influence, it could taper off with distance. The recursive calls, they were controlled using parameters such as range, radius, and strength. And this then offers us finer control over how the terrain is then shaped. So these methods, they are fairly complex, and they have, in our experience, led to a bit of performance issues and stack overflow when they're not carefully managed.